Okay. Good afternoon, everyone. We will start this session. Okay. Last session we are I'm not sharing the screen. Just okay. I think everybody's seen my screen and also audible. If I'm not audible or not seen the screen, please send the message on your chat box is there, or by unmute your mic and tell me. So this is the session of the interrupt is there. First, this is unit number. We are discussing the unit number 4 is there. In that unit, we had first part discussing the port structure of the 8051. Today, we are discussing the interrupt is there. See, in microcontroller or microprocessor, there are two types of the two things you have to disturb, or you can give any instruction to the 8051 or controller, or disturb, or you can say call the 8051 or microprocessor. There first is the polling method, and another is the interrupt method. One is the polling method, and another is the interrupt method. So these are the two methods by which you give the instruction to the main program of your 8051, or maybe any controller is there, and that controller or microprocessor will be stop their main program and go to the where the instruction is called, and it will go there and execute that instruction and come into the our main program is there. Okay, there are two methods which gives the service which a microprocessor can service. First is the polling routine and another is the interrupt is there. Okay, so what is difference between these two? What is the difference between these two is there? See, polling method means polling routine means what? If you are connected the input output ports to your 8051 is there. Polling method, suppose port number 1 you have to connect. In port number 1, uh, there are the 8 input device. Suppose you have to connect the input device. One is connected to the LED, one is connected to the LCD is there, and another is connected different input devices. You have to connect it to the 8051 is there. So polling method means what? You have to check the one by one the port is there. It has check one by one port is there from the check one by one from where the service is called from the input output is there, where from the service is called from the input. Suppose there are four ports are there. First it is check the port number 1. If there is any service from that, then check port number 2. If there is any services there, then check port number 3, or any services are there, or you can four services are there. If there is any service there, if suppose port number 3 is in the service, then first you have to check port 1, then port 2, and then port 3. And if port 3 is service, it is go to the port 4, 3 is there. After that, is check the port 4. Polling method means what? Is serially check the services which is coming to the controller is there. So this is called the polling method is there. So suppose your services come to the port number 4 is there, but he is not go to the direct port number 4. It is checked from the port number 1, serial is there. So it is a time consuming part is there. It is a time consuming part is there. So avoid this, we have to use the interrupt in 8051. Means if you give the interrupt to the 8051 or any service to the 8051, is directly take the service. It is not checked from the serially. It is not checked from the serially. So polling method is discarded, and we have to use the interrupt method is there. We have to use the interrupt method is there. Okay, means interrupt means what? You have to randomly give the flow of the connectivity is there, continuity is there. Okay, interrupt is that occurs randomly in the flow of continuity is there. Means what? You can randomly ask any service to your 8051. It is just like you are giving the example. If I see on the screen is that it is a someone is work, and depending on if there is a, it is like a call. If call is coming to you, then if you are doing the work, then depending upon the priority, you have to decide whether to attend or neglect the call is there. If you are in the doing the work is there, if his call is coming, then you have to decide this call is taken or attend or neglect is there, depend upon the priority of that call is there. If it is priority of call is important, you have to stop your work and take the call is there. If this call is not that much important is there, then you have to do your work is there. So just like interrupt is just like this. When there is an interrupt to the 805, then he decides the priority of that interrupt is there. If it is priority is more, then 805 is go to that interrupt and do the execution of that interrupt. Interrupt is such a another program is there. Interrupt is another program is there. In your C programming, just like if you call the function, it is go to from main function to the where it is go from main function to the this call functions and then function is executed after that it will go to the main function. Just like in 801, it is like an interrupt is another program is there. Interrupt is another program where you have to write down the instruction one by one, where you have to write down the instructions one by one is there, and that instructions are executed. Those instructions are executed means suppose your main program is 10 lines and then interrupt program says 20 lines is there. It is from the 10 lines where the interrupt is called, it will go to that 20 line program that execute that program and you will get the output is there. So interrupt is another program where some functions we have to do to stop the your current function or your current program is there. This is the interrupt. So interrupts are very important in 801. Why it is required? Suppose you are doing the program of your what, suppose there is a furnace and if there is a boiling temperature 1000 is there, and if you are by controller you have to control the temperature of that furnace is there, or you can say as a boiler is there. If you want to control temperature is exceed from 1000 degrees Celsius, then what will happen? There is interrupt is created in 805 and this interrupt give the instruction uh, to the your microcontroller that you have to first cool the boiler by using another method there where they are used, or you have to stop, you have to uh, turn off the flame of that boiler is there. So depending upon the interrupt is given to that, you have to decide the work of that. So interrupt is decide the work what we have to do by the 8051 is there. Okay, so interrupt is a disturbance, you can say, to your current program. In simple way, interrupt is a disturbance to your current program is then you have to decide the disturbance is good, this priority of this disturbance or priority of this, you have to select the priority of this, you have to select this disturbance is there, or you can say interrupt of there is there. So 8051 is having the 5 interrupts are there. Two internal interrupts are there, timer 0 and timer 1 are the interrupts are there. Two external interrupts are there, int 0 and int 1 is there. And one is a serial interrupt, is a serial interrupt with ri and ti is there. Receive interrupt and ri means receive interrupt, ti means transmit interrupts are there. Okay, so each these interrupts has a interrupt vector address. They have some interrupt vector addresses and where the interrupts are stored. The interrupts are stored into the interrupt service routines are there. Interrupts are stored in interrupt service routines are there. Interrupts are stored in interrupt service routines are there. ISRS say you can say the interrupt service routine where the address of the interrupt will be stored is there. Okay. So see, I will discuss the interrupt service routines. See, this is the interrupt structure of control, interrupt structure and control system of your 805. See, here the interrupts are there. See, this is the interrupts are there. Interrupt 0. This is the timer interrupt 0. This is timer interrupt 1. Interrupt 0. Sorry, interrupt 1. This is the RI and TI. They are giving the priority of these. This is the first priority of this interrupt is INT 0. Second priority of the interrupt is TF0. Third priority of the interrupt is INT1. Fourth priority is TF1. And another is the RI and TI is the interrupts of the receive interrupt, or you can say the serial input output interrupts are there. Okay. So this is the where we have to connect the interrupt. It is connected 0, or it is connected to the 1. Depending upon that, you have to connect to the I register is there. So I means E means enable. This here is individual interrupt enables, or it is a global enable. If I am connecting by using this, This is the only a single interrupt you have to connect. Suppose you want to connect your microcontroller is RI interrupt. By using this single interrupt, you have to connect to the RI interrupt. And here is universal. Universal means all interrupts are connected to your 8051. All interrupts are connected to the 8051, and depending upon which interrupt is coming, which service is coming, then 8051 select or take the instruction from the same interrupts are there. So this is the individual interrupt enables are there. These are the individual interrupts enables are there, and this is the global enable. Means you have to connect directly all interrupts to the 805. Then here is the IP. E means enable, I means interrupt, I means interrupt, E means enable. Here IP, I means interrupt, P means priority. It is interrupt priority register. It is the interrupt enable register. It is the interrupt priority register. Priority means what? Which interrupt is executed first. Suppose interrupt 0 having one function, TF0 is having one function, and INT1 is having one function. These three interrupts at a timely come to the 805. These three interrupts at a timely come to the 805. Means three interrupts come to the 805. Then which interrupt he has to take first? Which interrupts he has to take first? So for that purpose, they are giving the priority. This priority is given by this one. This priority is given by this priority register. There is a register software we are giving the priority to the 8051, and according to that priority, he select the one interrupt at a time. Maybe INT0, TF0, depending upon that is there. Okay, this is the IP register is there. We select the priorities there. We select the priorities there. So here is the highest priority interrupt is there. It is internal polling sequence is there, and low priority. It is high priority to low priority. Depending upon INT0, TF0, these are the high priority, and last one is the lower priority there. But you can give the priority of this interrupt by using a software is there. For that purpose, we have to use the one register. It's called IP register is there. It is 8-bit register, and IE is also 8-bit register. Depending upon you have to enable the all the interrupts are there. So this is the interrupt structure of your 805. This is the interrupt structure is there. So you can understand. So when you're online, if it is asked how many interrupts are there, we have 5 interrupts. We have 5 interrupts. Which are these? 2 interrupts are INT0, INT1, and 2 timer interrupt TF0 and TF1, and one is the our which interrupt? Serial interrupt is there. RI and TI is there. Okay. आता हे काय आहे? It is the interrupt service routine is there. Okay, this address where the control jumps after the interrupt to the service, this is called the interrupt service routines are there. It is the interrupt service routine. It is the name of the interrupt, it is the name of the flag of that interrupt, and it is the interrupt vector address where the interrupt is stored. Where the interrupt is stored. How you call the interrupts is there? When you call the interrupts, your interrupt will be connected. It is connected to the IE0 and interrupt. This is the address of it. Is called interrupt vector address, and it is stored in interrupt service routine is there. In that there is address, and in that address this interrupt is stored. Means when you call the interrupt, what you have to call? You have to call this address. When you suppose you call the interrupt 0 is there, then you have to call this address. At that address there is some instructions are there, and these instructions will be executed. These instructions are the executed. So this is the interrupt vector address. Please remember this interrupt vector address. It is required when you are doing the online examination is there. So this is the INT0, it is interrupt 0, it is external interrupt 0, interrupt 0, INT0 is there. This is the flag IE0, then 001 is the interrupt. See what is meant by the flag? What is the flag is there? See here, when your interrupt is 1, if it is your interrupt is 1, then it enable the interrupt is there. If it is interrupt is connected to the 0, then interrupt is disable. If it is interrupt is connected to the 1, interrupt is enable, and if it interrupt is connected to the 0, interrupt is disable is there. Interrupt is connected to the 0, it is disable is there, and if it is interrupt is connected to 1, it is the enable is there. So depending upon that, you can enable the interrupts are there. So here these are the IE0 are the flags. This is the timer 0 flag, TF0 is there. Then INT1, external interrupt 1 is there. This is the timer 1, TF1 is there. And this is the serial interrupts are there, TI and RI. All the highest interrupt is reset. Reset is also a interrupt is there. Reset is also interrupt is there. By using reset, you have to zero all the data is there. So this is the reset is there. Reset is higher priority interrupts are there. It is the higher priority interrupt. It is interrupt vector address is 000H is there. Okay. Okay. It is which I am discussing here, writing here is there. Here is the highest priority interrupt. It is the highest priority. Starting code is from 00H address is there. Okay. Then Intel interrupts are two interrupts of the Intel. These are the Intel interrupts are there, which are one timer 0 and timer 1. These are the internal interrupts of 8051 is there. Okay. These are the overflow flag. These are the overflow flag TF0 and TF1 is there. Okay, and the microcontroller jumps to vector addresses served into. For this global timer interrupt should be enabled is there. Okay, so these are the overflow flag. We are discussing the overflow flag when the timer will be completed there, 1 microsecond time is there, and it will be overflow and it is come to the zero is there. So then this is serial interrupts are there, ti and ri is there. Okay, this is the when last bit is stop bit, the byte is transmitted, ti serial interrupt flag is set, and when last bit is stop bit, the receiving data is received, the RI flags gets set is there. Okay. Ata, what is the meaning of start bit and stop bit there? Okay, here I am writing related serial interrupt flag TI and RI when last bit is stop bit, the byte is transmitted, and TI serial interrupt flag when last bit is the stop bit for receiving data. Suppose if you are transmitting or this is a serial port is there, there is SCON register is for that purpose we have to use their control register for the serial communication is there. When you are transmit the data, when you transmit the data, when you transmit the data, we have to start and stop bit is there. For what purpose is start and stop bit data? See, there is a transmitter and receiver. There is one transmitter where you have to transmit data, and there is one receiver where you have to receive the data. There is one transmit data where you have to transmit data, where you have to receive the data. Is another receiver there. So how can understand that receiver that all data will be transmitted from transmitter he has received? How can he understand that the all data will be complete coming to him is correct? So for that purpose, suppose you have to transmit the 8-bit. Suppose you have to transmit the 8-bit is there. After 8-bit, there is a transmit one another bit is there. After 8-bit, it is transmit one another bit, which is the 9th bit is there. So when 9th bit will become, then he can receive and understand that last bit will be 9th bit is coming. So our transmitter will be receive the data is there. So you have to receive the data is there. So it is the receive the 9th bit is there. So he can understand that all data will be received by him is there. Okay, so for that purpose, it is the stop bit is there. For that purpose, it is the stop bit is there. Due to that stop bit, the receiver can understand that whole data will be coming from the transmitter will come to the receiver end is there. All data is coming from the transmitter will be come to the receiving end is there. Okay, so this is the serial interrupt is there. This is the serial interrupt is there. Okay, you can understand this one. Next is the interrupt enable register is there, or discuss interrupt enable register is there. So you can understand the interrupt vector address are there. So here is the enable register. Please remember this. If there is offline examination there is a question for the 6 mark is there. There is a question for the 6 mark is there. Write down the interrupt enable register is there. Write down the interrupt enable register is there. So it is interrupt enable register is the 8-bit register is there. Interrupt enable register is the 8-bit register is there. So EX0 to EA is there. It is the 8-bit register is there. EX0 to EA is there. Okay. So here is the register is there. We will start from this EA is there. Okay. So it is the EA means enable all bit. So if it is 1, enable all the interrupts. And if it is 0, disable all the interrupts are there. So bit number 1 should be 1 is there. Bit number 7 should be 1 is there. Due to that, all bits will be enabled. All bits will be enabled is there. Okay. So 6 and 5, 5 and 6 are the reserved bits. 5 and 6 are the reserved bits are there. Okay. So that bit 4 is the interrupt enable serial interrupt bit. It is for S means serial, E means enable. Remember these things are there. This is the E means enable. E means where every time there is a E is there. So E means enable. Remember that E means enable because working with the enable register is enable is there. And this is S means serial. S means the serial bit is there. So enable the serial interrupt bit is there. So enable the serial interrupt bit is there. Enable the serial interrupt bit is there. So if it is 1, enable the serial interrupts. If it is 1, enable the serial interrupt is there, and 0, it is the disable the serial interrupt is there. Which are the serial interrupts are there? RI and TI is there. Serial interrupts are there, RI and TI are there. Okay. Next is the enable the timer 1 interrupt is there. Enable timer 1 interrupt bit is there. So ET1 is there. Enable timer 1 is there. Interrupt bit is there. Okay. So enable the timer 1 interrupt for 1 and disable the timer is the 0 is there. Okay. Then this is the EX1 is for the INT1. This is for the INT1 is there. INT1 interrupt is there. EX1 is there. If it is 1, it is enable. If it is 0, it is disable is there. The next is the ET0, enable the timer 0, interrupt bit is there. Enable the timer 0, interrupt bit is there. So enable the timer 0, interrupt bit is there, ET0 is there. Interrupt, enable the timer 0, interrupt bit is there. Enable the timer 0, interrupt bit is there. For the timer 0, if it is 1, timer 0, interrupt bit enable 0, disable there. EX0 is external, 0 interrupt bit is there. EX0 is external, interrupt bit is 0. So this is the enable the all the interrupts for using this is there. Okay. Suppose I am writing, if I am writing 1 1, if I am writing 1 1, suppose I am writing the instruction is move interrupt enable register. For example, I'm writing this interrupt enable I, comma, hash, hash, hash. I'm writing 8 1 H is there. 8 1 H is there. So what will the instruction? If it is 8 1 H means this is 1, this is 0, sorry, this is 0, this is 0, this is 0. So it becomes 8 is there. So here all it becomes 8 is there. Okay. 8. Okay. 2 raised to 3 is there. 8 is there. And after that, if I'm writing here is 1 means 0, 0, 0 and 1 is there. Okay. 8 1 H is there. So only which interrupt is enabled? Only EX0 interrupt is enabled. Only EX0 interrupt will be enable is there. Only EX0 interrupt will be enable is there. Okay. So it is only EX0 interrupt will be enable is there. Okay. So this is the 81H is there. So this is the 81H is there. Instruction is given. The interrupt enable will be interrupt which is the external interrupt 0 will be enable is there. So this is the I register is used to enable and disable the interrupts. We are discussing the I interrupt at the time of the first SFR. This is a special function register. This is a special function register. We are discussed at the time of your, we are discussing at the time of the architecture is there. So here this is the interrupt enable register is there. Okay. Next, this is the priority I'm giving this. This is the priority of the interrupt is given. IP is the priority register is there. Interrupt priority after the reset is there. If you reset all this, and how do the priority is given? First interrupt will be executed is INT0 is there. First interrupt is you have to use the INT0 is there. Interrupt bit is the INT0 is there. Second interrupt you have to execute is TF0 is there, which is the overflow flag of the timer 0 is there. INT1 is interrupt 1 is there. And then timer interrupt is TM1 is there, and then serial interrupt is TI and RI. Serial interrupt is the TI and RI is there. So these are the interrupts we have to give the priority of your, this is the highest priority to the lowest priority. This is the highest priority, which is H, and this is the lowest priority of the interrupt is there. So INT0 to TI and I is the highest and lowest priority of the interrupt is there. This is the highest and lowest priority of the interrupt is there. Okay, understood. This INT0 and TI and RI is there. Okay, so remember this, how many interrupts are there? 5 interrupts are there, and these are the interrupt priority of the. So how to take the, if you want to give the priority of your interrupt, this is the highest priority by reset. Means if you are not, if you are not giving the priority by using IP register, you have to only enable the all the interrupts is there, and all the interrupts is coming from the outside to your, or maybe internal outside interrupt is coming to the 80 then how can he decide which interrupts take first? How can he decide which interrupts take first? Means same that if there is a call from the outside, then who is decide? You decide that which call you have to attend or not. But in a processor, how can processor understand this interrupt will taken or not? So for that purpose, when reset all the IP register is there, when IP register is 000, then if all interrupt is coming from your 805 coming to the 8051, then he takes first interrupt is external interrupt 0, then next take the timer 0 interrupt, then next take the interrupt 1. These are the priority of the interrupt is there after the reset of the interrupts are there. After the reset of the interrupts are there. Okay. This is the priority is given, and you can set the priority. You can set the priorities there. You can set the priority by using this IP register is there. You can set the priority as being the IP register is there. Okay. This is the, see, there is a same address from if you see this from port number, sorry, bit number 4 to bit number 0, same is there. PS, PT, P means priority, serial port, then timer 1, external interrupt, timer 0, and external interrupt 0 is there. Here is also same is there, in enable is there. See, same is there, it is S, timer 1, external interrupt 1, timer 0, external 0. Only you have to remove the enable interrupt is there. Here we require to set the, you have to require to set this is enable interrupt should be 1 is there. So here is the same as T, only you have to replace E with the P is there. You have to only replace E with the P is there. You have to only replace E with the P is there. This is the priority is there. This is P shows that the priority of the interrupt is there. Okay. If it is 1, then you have to assign the priority. If it is 0, you are not assigned the priority, or you can say low priority of the timer 1, or 1 is the highest priority of the timer 1 is there. But suppose if you write all the 1 is there, if you suppose write all the 1, then which interrupt you have to take first? Again, it goes to the reset interrupt is, which interrupt is INT0 interrupt would be first is there. But if you are not reset the port IP is there, then you can decide which interrupt is given first to the 8051 by using only put one value into this is there. Okay. Suppose if I want to give the timer 1 interrupt as a highest priority, then what we have to do? You have to only put a value of 0. Sorry. If you want to give this interrupt is, if you want to give this interrupt is first, you have to give the 1 is there, and you have to put 0 0 to all other interrupts are. You have to 0 0 to all other interrupts are there. So this PT1 will be executed first. This PT1 is executed first, and then if there is other interrupts are there, but depending upon the 8051 priority, it will be interrupt is there, because by 8051 interrupt, first he should be execute the interrupt of the PX0 is there. But I am giving the timer 1 is their priority, set the priorities timer 1 is there. If there is from PX0, it is goes to the PT1 is there. See in your 8051, there are trap and 6.5 and 6.7 interrupts are there. I think in 8051, there are the interrupts are. Yes, I want to open the unit 1 PPT is there. Okay. See, in your 8085, we are discussing the previous first two lectures. Here are the interrupts are there. Here are the interrupts are there. One, two, three, four, five. Here is no, there is no any here. There is a no any priority register is there. There is no any enable register is there. Here we have to use these interrupts are there. Here is a use the interrupt session. And telling at the time there is a highest priority interrupt is the trap. Highest priority interrupt is the trap interrupt is there. Highest priority interrupt is the trap interrupt. Highest priority interrupt is the trap interrupt is there. And 7.5, 6.5, and 5.5 are the other interrupts which is having the priorities. First is I 7.0, then 7.5, then 6.5, and 5.5 are the interrupts. These are the extra, these are the interrupts which are present in your 8085 is there. Understood? And trap is the highest priority interrupt. Trap is the highest priority interrupt. And in our 8051, 8051, there is a interrupt is, which interrupt is there? This is a INT0 is the highest priority interrupt. INT0 is the highest priority interrupt is there. Okay. Okay, understood. This is the priority of this given is there, and these are the five interrupts. Trap 7.5. That's why I'm comparing with this 8085 and 8051 are there. There is no I register is there. There is no any IP register. There is priority purpose is there. They are directly priority of the given by the trap 7.5, 6.5, 5.5, and INT is there. These are the priority. You are not set the priority of your interrupt is there. But in 8051, you have facility to set the priority of the your interrupt is there. But if you are not set the priority of the interrupt is, then by default he takes the priority of INT0 and so on is there. So there are two facilities which are present. There is no present in your 8085 is there. There is no present in 8085 is there. You can't set the priority of the interrupt is there. But here you can set the priority of the interrupt is there. Okay. So this is the priority of the interrupt is there. This is the 80 priority of the interrupts are there. Okay. Then you have to activate the interrupts are there. You have to activate the interrupts are there. So we have to use the activation level for the two types of activation level of the 8051 is there. So if you are learn the flip-flops are there. If you learn the flip-flops are there, JK flip-flop, T flip-flop. Have you learned the flip-flops? Hello, have you learned the flip-flops?
Yes, sir.
Okay, so you learn the flip-flops up there. So these are the JK and T flip-flop equivalents. You have to change the state of this flip-flop. You have to change the state of this flip-flop. Suppose flip-flop is contain value of Q is equal to 0 and Q bar is equal to 1. And if you have to change the state of the flip-flop, then at that time you have to give the trigger that flip-flop. After the trigger means what? You have to give the clock pulse to the flip-flop. Trigger means what? You have to give the clock pulse to that flip-flop is there, and due to that trigger, it will change the present state. Due to that trigger, it will be changed the its previous state is there. Same thing is there. If you want to activate the your interrupt is there, you have to give the trigger is there. So there are given 805 activation two trigger level is there, low level trigger level and falling edge trigger level. Low level trigger level is detected for INT0 and INT1, and falling edge trigger also detected for the INT1, INT0, and this is for the external hardware. External interrupts are, see, we have a internal interrupts are timer 0 and timer 1. This is not used for interrupt, internal interrupt. It is a external interrupts are there. For that purpose, we have to use the two level is there, two triggering level is there, low level trigger and falling edge trigger. See in diagram how this is here. See this line. Just I'm reading this. When falling edge is detected, okay, falling edge detected, interrupt service jumps to the interrupt service routine, ISR. Please remember this interrupt service routine to serve the interrupt. Interrupt service routine is the service routine where you have to store the address of that interrupt is there, which you have to call. Which we have to call this address is stored into the interrupt service routine, maybe INT0 or INT1 is there, and after that it will be uh, call, and it will be means sorry the 8050 jumps to the interrupt service routine and take the instructions from that, where you have to execute the instructions are there. Okay, so this is the falling edge and level. The falling edge and low level just to discuss in diagram is there. See, here it's called the falling edge for the toggle output on P0. This is the falling edge. Okay, means see, we are giving here. If this is the falling edge is coming, falling edge is coming. The output is suppose one. If output is one, after next falling edge, the output becomes a low is there. Toggle output of the port one. This is the is given a program is there by using that program. If interrupt is take a falling edge, then after that our output of port 1.0 will be toggle is there. If it is one, it will be go to the zero. If it is first toggle pulse, then it is go to zero. Okay. After that, it is the second triggering is lower than this is the again it will be one is there. After next it will be become a zero is there. So this is the clock cycle is there. This is the clock cycle is there where you have to okay. So this is the train impulse or INT0 pin is there. Okay, so there are two trigger impulses given. Just time to discuss which are the trigger impulses are there. See, first is the low level triggering. When level is detected, INT0 is low level triggering. Second is falling. Low level triggering means what? See, this is the falling edge. This is the falling edge trigger is there. This is the falling edge trigger means from 0 to 1. Edge means you know that edge means what? From 0 to sorry from 1 to 0. From 1 to 0 is called the falling edge. Means edge is coming from 1 and goes to the 0. This is called the falling edge triggering. If it is come from 1 to the 0, it is called the falling edge triggering. Chaos to 1%, 0%, it is called the falling edge triggering there. Here is here is another edge is there, but this edge is from 0 to 1 is there. So it is not a falling edge. This is a up. This is the negative triggering. This is a positive edge is there. This is the falling edge. Or it is called up edge. You can say, or you can say the positive edge is there. So from a negative to means 0 to 1, it is the upcoming edge, or you can say as a positive edge is there, but here is a negative edge from 0 to 1. So your interrupt will be activated or interrupt will be triggered when your input when your trigger is from the higher to lower, or it is called a falling edge is there. Another triggering method is the low level triggering. This is the low level triggering. This is a low level triggering. You can say these are the low level triggering is there. This is the low level triggering is there. Means you have to give the 0 0. This is the low level triggering. You can give the 0 0 is there. Okay. So these are the high level triggering. If you are discussing your flip-flops are there, you can give any clock pulses. You can give the clock pulses as the lower edge. You can give the clock pulses higher edge. You can give is a, as a edge trigger, means you can give the positive edge trigger. You can give the negative edge trigger. You can give the uh, level triggering means positive level triggering you can give, and you can give a negative level triggering also. Positive level triggering also you can give, and negative level triggering also you can give in the flip flop to change the its state is there. You have to change the state of this. So you can give any change, uh, any triggering pulses to your change the fluid. But in your interrupt, there are the restrictions are there. In that interrupts, you have to only two triggering pulses are there. First is the falling edge, next is the negative level triggering. Falling edge and next is the negative level triggering, or falling edge triggering or low level triggering is there. You can see negative edge trigger, negative triggering or low level triggering is there. Okay. So remember these 2 points regarding to the interrupts are there. Next part is the timer. We will discuss the timer in next lecture. Just want to give some brief of that and then we will stop. Okay. First part of this unit, we are discussing the ports are there. Next part is the interrupt is there. Okay. So we have a program of the interrupts is there. For the program of the interrupts, we have to design, you have to uh, draw a square wave of they are giving the some frequencies there, and you have to design or draw by using program. You will get the by using this program, you have to generate a square wave is there of some frequencies there. For that purpose, you have to use the two methods, is by using interrupt method or by using your timer programming is there. So we will discuss the program of the timer when completion of this. Next part is the timer. So there are some programs are there, by using that you have to generate the square wave, but you can't see the square wave on your uh, scale software is there. If you have time, then you can see, can we see the square wave by using Kale software? Is there any facility in your Kale software? Because you are a third year students, lots of software you have to learn by yourself is there. So I will, I am giving the some idea about Kale at the time of the practical session. So see, if you have generated the square wave, if you have generated the square wave, can it possible to see the square wave on your Kale software? Can it possible to any facility to see the square wave or any CRO on your Kale software where you can see the square is there? I'm show your square wave by using a which one port method is there. I'm showing the square wave by using the port method is there. If you want to see or any another simulation software, please check this. If you are in any simulation software, from that you can see the square wave on your screen is there. Okay, in Kale software there is any facility to see on a Kale software the square wave is there. Okay, so we'll discuss at a time of the practical session is there. So these are the this is the homework. This is the homework. I'm not uh, giving any idea of this. This is the homework, purely homework. You have to search this and see how to get the square wave or how to see the square wave on you using the Kale software. See, there is a CRO in your laboratory. What we have to use the CRO, or you can use the DSO where you have to see the square is there. Here we have to connect the ports are there. In practice, you will discuss the one program is there, on off is there. We discuss the port 1.1. You have to bit is on and off is there by using the call delay is there. So what 0101 will be there is there. Here we can see the there is a possibility to see the square wave on your screen is there. Okay, we'll discuss this, or you can check this in your skill software is there. Okay, so this is the interrupts are there. So this is the interrupt. The important points of the interrupts are there. This is the one interrupt point. This is the architecture of the organic structure of the interrupts are there. In that interrupts, we have to use the priority, and this is the interrupt service vector address. These are the locations or vector address. In that vector address, you have to store the programs of your interrupts are there. So these are the TF0 and TF1 are the overflow flag. Overflow flag means what? What is the meaning of the overflow flag? See, we're discussing the overflow flag in your 8051 flag register. We're discussing the overflow flag in 8051 flag register. When you give the timing of 2 microseconds, suppose you are design a square wave of the 2 megahertz or 3 megahertz are there, which you have to calculation, you have to timer time will be 2 microseconds, because you have to convert this timer frequency in hertz, you have to convert it to the timing is there. You know that T is equal to 1 upon F is there. Timer time is equal to 1 upon F is the means F means frequency is there. If you want to generate a frequency, you have to select the time of that square wave is there. Okay, understood what I'm saying? See, this is the frequency. Frequency means this is the frequency means you have to time means time is equal to 1 upon F is there. You can say this is the timer there. So you have to calculate the time, then calculate the time, and you have to give the delay. What is a square wave means? What is a square wave means? Square wave means what? There is a on and there is off. There is a on and there is off. So this is the delay time. This is the delay time where this portion will be stay on, and after that you have to give the delay time. So this portion will be on is there. So in delay time, so you have to decide the delay time, and you have to calculate this time, some method for calculate the delay time for the 2 megahertz, calculate the delay for the 10 megahertz. For the frequency, you have to calculate the delay time to stay your square wave for that time is there. So you have to give the delay, and for that purpose you have to use the timer is there. Okay, so this is the overflow flag. Overflow flag means what? This time discussing this. Overflow flag means what? After, if I am giving the starting point of your square wave, starting point of the square wave, if it is this one, after this If it is a 1 microsecond, if I'm saying, for example, it is the time of the 1 microsecond. After 1 microsecond, it completes its target. It completes target of one. After that, it will create a overflow flag. After that, it will create a overflow flag. Means what? You have to go to the highest to the lower is there. If we check the overflow flag, it is goes to the highest to the lower, and then again it is stopped for the 1 microsecond. After completion of the 1 microsecond, it will again overflow this. It will go to this. Means overflow means what? He completes its it completes its timing of delay time is that after that counter will be again zero. Means if you can see the counting, suppose you have to delay time means what is meant by delay time? Delay time means the counting is 0 0 to F is there. Counting is 0 0 to F is there. 0 0 to F is the counting is there. So for that counting 0 0 to FF is there. After this FF, the counting should be zero. After this FF, the counting should be start from the zero. Means you can say that after FF, your flag will be overflow. Flag will be one. And if it is set the one, then our timer understood that you have to complete our delay time. So you have to start the delay from zero is there. So for that was this TF0 and TF1 is the overflow flag for the timer zero and timer 1 is there. Okay, understood. This is the overflow flag for the timer 0 and timer 1 is there. Okay, we discuss these points are there. This is the interpretation. Just give the basic idea of the interrupts are there. So timers, next part of this unit is the timer is there. Next part of this unit is the timer is there. Our 8051 having the two timers, timer 0 and timer 1 are there. Both timers are the 16-bit wide. Both timers are the 16-bit wide is there. So you can have the two separate 8-bit timers are there. Maybe your 16-bit timers, but you can work with the two separate timers are there. We can work with the TL0 and TH1. See, here I am giving this timer. See, this is the timer 0 and timer 1. Timer 0 and timer 1 are the 16-bit timer. Okay, timer 1 and timer 0 are the 16-bit timer are there. So in your architecture, you can use a separate 8-bit timers. You can do separate 8-bit timers. So this is timer 0 and this is a timer 1 is there. Timer 0 and timer 1 is there. So this is a timer 0 for the 8-bit and timer 0 for the means higher lower 8-bit and higher 8-bit timer you can activate. So here is also lower timer 1 and higher timer 1. So we can use the separate timers of the what where we have to require such a things are there. Suppose you have to do the counting purpose because timer and counter is there. If you want to do the counting purpose is there. Suppose I want to count to the 7. Suppose I want to count up to the 7. Then what we have to do? There is need to take the all the timer 16-bit timer. No, we don't require all the 16-bit timer there because your 7th will be started from 0 0 0 to 1 1 1. So how many bits are required? 3 bits are there. Okay, we require 3 bits are there. Suppose you have to do the 16-bit timer there. 16-bit means you have to start from 0 0 0 0. So you have to require F F F is there. Okay, so this is the 16-bit is there. This is the 16-bit is there. So for that purpose here we have to use the 16-bit whole timer. Here we have to use the 8-bit timer is there, where we have to use the 8-bit timer is there. So depending upon the counting purpose, you have to set the timers priorities there. So for that purpose, they have to use the mode of this 805 timer is there. Mode 0, mode 1, mode 2, and mode 3 is there. In each mode, they have to use the timer. In one mode, it is act from 13-bit timer. In another mode, it is for the 16-bit timer. Then another mode, it is only act as a 8-bit timer is there. So depending upon the requirement of your counting purpose or for your delay time is there, you have to set the mode of these timers, and then by using that mode, you have to uh, we have to set the you have to set the timers. We have to select the timers priority. So this is the timers are there. We discuss next part in the next lecture of the timer is there. So this is the 16-bit timer of your 805. So if you have any difficulty, ask me regarding this. Regarding this interrupt session, if you have any difficulty. If any query regarding this session is there, I want to give the 2 to 5 minutes are there. So see, there is a program for the interrupts also, and there is a program for your timer also. There is a program for the interrupt also, and there is a program for the timer also.